Welcome back, everybody. And last video, I will give you the introduction to the descriptive geometry, and now we're gonna learn how to find the true length of a line. The step to find the true length of the line is to draw the flow line parallel to the line first, and then you label the flow line appropriately. Extend projection line from the end of the line into the auxiliary view. Transfer endpoint distances from the flow line in the second preceding view from the one being drawn. If you look at this example here, um, you first you have all this point A, B at the top view, and then you have the same point A, B, but then it's at the front view, and then a point you have a point A, B on the right side view. Now you're gonna have to project the auxiliary view, and by drawing a line that is parallel to the line BR and AR, draw the 90 degrees perpendicular to the flow line, and then project them 90 degree to the auxiliary view. So once you have that established, you're going to measure the distance. Always skip the view to get the distance. So this x transferred to here, y to here, and this would be your true length of the from the auxiliary view. And now let's find the point view of a line. So the point view of the line, the same process. First thing you would want to do is to find the true length of the line. What is the true length of the line? The true length always on the auxiliary view. So this would be a true length. And now draw the flow line perpendicular to the true length line. You're going to draw a line here perpendicular to the true length line, and then label the flow line appropriately. So you will label them auxiliary view here, and then that's your second view. And then you're going to measure the distance, whatever the distance here, transfer the distance here, that would be the point that you want to establish. And let's get to the topic to see how we're going to find the true distance between a line and a point in a space. Given a line on the front view and the right side view, and always label them with point AB, about the same point AB, but then it's at the different view. You have a front view, so you label them A at the front view, B at the front view, A at the rear view, and B at the rear view. And then with the you're going to draw a parallel to your front view. This is your flow line that draw parallel to your front view, and then project all this line here perpendicular. You're going to draw 90 degree perpendicular, draw it out, and then you're going to measure x, measure z, measure y, transfer this distance onto your auxiliary view. And then once you have that, you're gonna connect this dot, and once you connect this dot, you have a true length. And this point CA is, you call them CA, the C point, but it's at the auxiliary view. So you have a C point here, C point there. All these points are related to each other, and that's how you establish that point. And the last step is you're gonna have to find the true distance between the line and the point. So you're gonna, again, once you have that point CA, now to find the true distance, you're gonna have to do the same thing, draw another line that is perpendicular to this the true length, and this perpendicular line, draw another perpendicular line. This distance here will be your true distance. So this x and the y will be your true distance from point A and B. So you want to find the distance between here and there, and that's how you have to determine that distance here. So again, once you transfer this xy over to this B view, so then once you establish a 2 point, and then you can measure that true distance, and this distance is going to give you the true distance from line A to a point. So the distance from here to here is the distance from here to here. And now let's find a true distance between two parallel lines. Let's say given two parallel lines, and I want to find the true distance between these two parallel lines. What is the true distance between these two parallel lines? To find that, again, same process. Skip a view to transfer all this distance onto this auxiliary view, and you have two parallel lines. Draw the fold line that is parallel to this two parallel line, and then once you have that drawn, now you're gonna have to create another fold line, and you're gonna transfer all the distance from xy to this xy. So you have same thing, x here is equal to this x, y to that y to give you this 2 point here. So once you establish this 2 point, you can just measure the distance between line AB and line CDB. So once this is going to be your true distance between line ABB and CDB. So B is your secondary view that would give you the true distance. So how do you establish this point? Same thing, project perpendicularly to this fold line. From here, measure this distance. This distance transferred to the auxiliary view. That's how you establish this two line. So I'm going to go on to the next method here, and this method here is to find the true distance between two non-parallel lines. So you have two non-parallel lines, and you want to find the true distance. Same process. When you get to that this front view and the rear view, you're going to get this auxiliary view by projecting this perpendicular to the flow line. And then once you establish this two line, this is all true length of AB, and you can see this is the true length of AB, but it's not this. Why? That's because whenever you have a parallel, when you draw the auxiliary view, one is parallel to that particular line, that means that's the true length. If it's not parallel, then it's not the true length. For this case, CD is not the true length. And then once you have that this two line here, when you get the true length, you're going to project this true length perpendicular to the fold line, perpendicular to it, and measure the distance here from here. So you're going to project here, right? And then you're going to measure distance here, transfer here, and here to here, and so on. Once you have 2 points, then you connect this 2 point. And that's to find the true distance. And this line here, when you project this line to your secondary view, this line become a point. This line is going to be a point because you only can see 1 point at the same distance. As you can see, this distance here equal to this distance. When it's equal to the distance, you simply get just 1 point. So to get the true distance between two non-parallel lines, so that will be the distance between the two parallel lines, as you can see here. So here is the true distance of the two non-parallel lines. So you're trying to find out where the distance is. You got this line here, CD, this line here, and so what is even though this is not parallel, what is the distance? And to get the distance from here to here, so they're not actually touching each other, they have that distance, that true distance away from each other. And I'm gonna end this video 2 here, and we're gonna continue on to project a plane into another view.